Okay, guys, what I plan on doing today is just like I did with second hour. I went through about 5 or 6 of them, and then I'm going to give you guys the secondary sheet of this, and of that sheet I'll give you a couple more over the weekend. We'll go from there. On Monday, what we'll do is we'll start putting some of these identities back into equations. And when we put the identities back into the equations, they're not as complex as some of these are because it's kind of hard to write equations like that to make them work. So let's go from this one. Now, in this one here, my best guess is that if you'll notice, your denominator has what do you call it? Inverses of one another, okay? So I know right away they are inverses of one another. And that I can also rewrite everything in terms of sines and cosines. The way that I usually think these things through is I usually jump right to sines and cosines just because that's just how my mind thinks. So if I do that, I'm going to get my numerator becomes sine over cosine because secant is 1 over cosine. Okay. Big denominator then becomes sine over cosine plus cosine over sine. We'll be okay with that. Now, the big denominator now has an addition part to it. Whenever I see addition, I want to try and get a common denominator. What is going to be the common denominator between a cosine and a sine?
Cosine sine.
Very good. So I have a cosine sine here. Numerator becomes, well, fraction on the left needs a sine. Fraction on the right needs a, what does that become for that numerator?
Why are they 1?
1. What's that?
Why are they squared?
Oh, what's sine times sine? So I get a 1 in the numerator. I still have a cosine sine here. Up here is a sine cosine. And now is when I have to do my flip. So when I multiply by my reciprocal, I get sine over cosine times cosine sine over 1, and what drops? Cosines. Sine times sine is? Sine squared.
Why wouldn't it be 1 over cosine sine? Because wasn't it squared in the numerator? Why is it cosine?
I'm sorry.
Wait, if these two are squared, why does this become 1 and this?
Oh, Pythagorean identity. What's sine squared plus cosine squared? Yes, sir.
Because cosine, minus sign, I want the minus sign be a
Guys.
negative.
Hold on. Please.
Because it's cosine minus sign, I want that to be a negative sign. So instead of negative sign, make a negative sign squared.
Whoa. It's cosine times sine.
Oh.
I did because it was cosine sine at the bottom.
There's subtractions in it.
I apologize. Yeah, it's a cosine sine. Sorry about that. Okay. It's okay. Yeah, I've been known to screw up on these things. You should have saw me second hour. I got into one of the problems on second hour, and I was going through this whole thing, and I went, oh crap, that's not going to work.
I like yesterday at this class.
Yeah, pretty much. It happens a lot with these things. And then Federici goes, hey, don't you realize those are inverses? I went, oh. So it really only took 2 steps as opposed to like the 9th step that I was on. Then people are furiously erasing things. I'm like, just cross it off and start over. So that was 3. What was the other one that you had issues on?
8.
All of them except for 4, 5,
So this one's a little tricky in that if you rewrote tangent squared in terms of sines and cosines, you'd wind up with like a sine to the 4th, and that just doesn't look like any fun.
Yeah, that's what I started.
But if you look at where you start and then look at where you end, notice you start with multiplication, but yet you end with subtraction, which means that somewhere along the way, you probably had to use one of the Pythagorean identities to show that there was some addition or subtraction going on. So what I would do is, in my mind here, I'm seeing this, I know that I have cosine squared plus sine squared is 1. I know that 1 plus tangent squared is secant squared. And I know that 1 plus cotangent squared is cosecant squared. So if I manipulate some of these things, there's got to be a way that I'm going to be able to rewrite them to get a subtraction, which means sine squared is 1 minus cosine squared. This is how I'm going to get my subtraction. So what I do then is I rewrite as tangent squared times 1 minus cosine squared. Okay so far? Now, when I do that, that's just telling me to distribute. If I distribute, I get tangent squared minus tangent squared times cosine squared. What is tangent squared? Sine squared over cosine squared. So I get tangent squared and what drops?
When I get home, just like, why doesn't this make sense?
Where did all the numbers go in math? Why are there these letters? Please make it go away. Okay? I've been getting that a lot lately. When do we get numbers again? Why can't they come back? Hey, on a good note, we start with numbers again next week, which means next week you guys get to use a calculator again.
Yay! Yes, finally. I always do really good. It's calculator. It means that the math is hard enough. I need a calculator. I like that.
You guys are always so optimistic.
You want us to start chanting calculator or something?
Yeah. LeBlanc, what do you got? Wait, huh? 10? Do you have $1? Oh, I didn't get the whole thing.
I don't know why, but my sheet got super backwards.
No, you're not the only one.
I need like a giant eraser.
Yeah.
Okay. Now, I cannot drop and rewrite these things as sine plus cosine to equal 1 because they are not squared. Okay? So, what I have to do is I could FOIL. If I FOIL this, I don't know how well that's going to get me there, but let's just see. So you have sine, tangent.
Yeah, I'm not gonna write it until I see how it works out.
It's probably a smart idea. All right, in my mind right now, I'm saying, okay, this isn't going to be so bad. Because now, if I do that, I'm going to rewrite all the tangents and cotangents in terms of sines and cosines. Now, each one of these guys, each one of them become, for each term, they all have a denominator that works, sine times sine over cosine, sine cosine over sine, and so on. So I can simplify this stuff as I'm going. I'm going to get sine squared over cosine plus cosine plus sine plus cosine squared over sine. So far, so good? Yes, no, maybe so? Okay. Now, again, I'm back to a super awesome looking, what do you call it? Equation. Thank you. It's not an equation. Oh, God, this doesn't call it. So if this is over 1, maybe this wasn't the easiest way to do it. Oh, I royally screwed something up here.
Oh my. Okay, this is bad. No, that's how
Can you do the way that you were gonna do it another way?
This can't be that difficult. No, I got a better idea. I got a better idea. Tangent and cotangent are inverses of one another. If I get a common denominator here, it'll be tangent, which makes this tangent squared plus 1. What's that?
Look over your notes so you knew.
Maybe. So then I have you okay with that?
Sure. Oh, wow. I looked away from
Miss a little, miss a lot. Now I'm going to look at just this. I'm going to look at just this portion real quick, because that can be rewritten. That can be rewritten as a complex fraction. Here's what I. Poor Artie. What? So this is 1 over cosine squared divided by sine over cosine. Secant squared over tangent.
No, I understand, like.
Oh, why? I'm just throwing darts to see what sticks. So now here, I can multiply by the reciprocal. Which is going to give me.
I didn't know that secant squared was 1 over cosine.
I was thinking it was written down. Anytime you have like cosine is 1 over secant, so cosine squared is 1 over secant squared. Cosine to the 5th is 1 over secant to the
That would
5th.
have been really nice. 'Cause I
All
didn't
those were. I thought I did one like that yesterday. I swear I did.
I didn't realize we could like make them squared.
Gotcha.
I thought the only thing we could do was the cosine squared.
1 minus sine squared. Oh, of course. Go for the water bottle.
So that gives me. Yes, ma'am.
Where did you get tan squared plus 1 over tan again?
Here. I went for the idea that tangent and cotangent are inverses of one another, which means if I rewrote them in terms of one another, I can get a common denominator. This is actually going to be how we solve this one, because now I have a singular term, 1 over, I have a singular term of 1 over cosine sine times a binomial. If I distribute backwards in, yes ma'am.
Is there going to be anything that's complicated?
There could be, you never know.
Ran out of room.
Again, what I noticed at the very beginning, and I can't use any Pythagorean identities off the bat because nothing's squared. But I had one binomial, tangent plus cotangent, that those two are inverses of one another. Knowing that those two guys are inverses of one another, that allows me to rewrite them as tangent over 1 plus 1 over tangent. If I add those two fractions together, I need a common denominator. 1 second, Hop. I have tangent then.
Oh, I see.
This fraction needs it, so you get tangent squared. This one didn't, so it was a 1. Tangent squared plus 1 is secant squared. 1 second, Hopper. I'll get you to Hoppenworth. Or do you have an easier way?
No, I was just raising my hand.
Okay.
You said you'll get to me, I was still like, oh, okay.
At that point, I knew that I wasn't going to be able to get anything else out of that unless I wrote it as a complex fraction. When I go to complex fractions, when I start working complex fractions, that allows me to do the big the 4-part fraction. If I move the bottom part, I can flip it, and the next thing you know, I'm multiplying by reciprocals. That's kind of like a nasty way of having to set some of these things up. Okay. I don't think there were any others on there that were that awful. This one might have been the toughest one on there.
I didn't see
Okay.
on this one, I got, and then on this one, I got,
Okay, what was your question though, Hopper?
for number 1, on the second page, how come they put 1 over secant instead of just cosine?
So,
Second page.
yeah, so there's just number 1.
Oh, yeah.
I don't know. I would have said make it equal to cosine. Maybe they just said, okay, you can stop there. That's all.
Because then I went to cosine before, because you have to take it from cosine and take it back to.
Oh, you do? Okay.
So I was just like.
You know, there's this crazy thing called the internet that I find stuff on. And I bet you anything, if you Googled trig identities worksheet 3.4, you probably could find a worked out solution key. Is it worked out too?
Yes, it is.
You?
Really?
Yeah, you didn't think the sheriff
I just like, you know, low quality.
You guys have it.
Yes, except I do.
Yeah, but I'm the honest
All the
worker.
biology.
Well, no, and that's the other thing. I mean,
No,
it's there, but guys, I told you guys before, when the internet came out, that's kind of how a lot of us passed college calculus because of the proofs. No, we would Google this beginning of a proof and we would find the proof and that would help us do our homework, which a lot of times with these things is you start to learn how to build into it. When you're looking at back and forth of like how did something get started, you can figure it out after a while. There's nothing wrong with that. It's homework. I mean homework, whatever. Try your homework. The internet is crazy. What's that?
I said I wish more teachers like that.
But I give you worksheets all day long, and I'm not going to sit there.
I just learned a breaker so when I don't do my actually do my homework.
What other ones do you want to look at, guys? Which other ones do you want to look at?
Usually don't.
Can't do all of them. Line, pick one, pick one.
13.
13. Ooh, I love this one.
You love
This one's fun.
Oh, yeah.
I never used it.
You just have all them worked out on second hour. It's like 16, pull it up, and you have it all set up.
Okay. I just want to remember how I started it. So, okay. So in this one here, what throws you for a loop, besides that, what kind of messes you up is that sine cube. So what I want to do is rewrite this right away as cosine plus 1 over sine times sine squared. Okay? In doing that, that gives me a cosecant right away. Okay? That gives me my cosecant here with this sine part. Because when I multiply it in, excuse me, that's the same thing as saying 1 times the sine, which means I already have a cosecant portion taken care of. So I have a cosecant times cosine plus 1 over sine squared. I'd be okay with that.
Wait, why did you just take the cosecant out like that? Because you couldn't take it out. Oh wait, yeah, you did. Never mind.
Okay. So now, if I look at the parentheses, what's wrong with blood?
Where did you get the cosecant?
Sine squared times sine gives me sine cubed. You okay with that? 1 over sine is cosecant. So I'm just moving that out of the way right now because I know I'm going to have to move it eventually. Sine squared in terms of cosines is what? It's 1 minus cosine squared. So in my parentheses now I'm going to have, I have a cosecant times the quantity, cosine plus 1 over 1 minus cosine squared. Now comes the tricky part. Is 1 a perfect square?
Yes.
Is cosine squared a perfect square?
Yes.
Is that a subtraction symbol?
Yes.
Therefore,
So you can do a difference of squares.
it's a difference of squares in the denominator.
Is that a good thing?
Lucas loves that. I hear him do his.
What drops now? Is 1 plus cosine and cosine plus 1 the same?
Oh,
No, no, no.
So these make so much sense when you like showing us the steps and stuff.
what does that mean?
I don't know, something Latin you put at the end of a proof. QED.
Is that what you found out in your calculus class?
Yes. Our professor wrote it down and I said, sure, all right. I don't remember, it stands for something. Quantumless, educationalist, doneness.
I'll take that. That's a good answer. Can I start writing that on my test?
What is it? It's Latin, I know that. What is it?
I don't know how to say it.
It.
It means that which was to be demonstrated.
That which means to be demonstrated.
That which was to be demonstrated.
That which was to be demonstrated. It is.
Demonstration.
Quad erat demonstratum. See, you guys didn't know you'd get not only crazy math, but you'd also get crazy Latin.
For the Latin.
Exactly.
What else we got?
16.
Not but good Latin.
Okay, it's because we're in American.
Okay. 16.
Oh no, I did not. I wrote something down. I got it.
I don't like the Y's.
I should rewrite it.
Just make the big X's.
So I'm going to go with sine plus sine over cosine. And did this. Work with this denominator first. I'm going to get cosine plus 1 over cosine. And so you have two denominators now. Are you all right with that? Multiply by the reciprocal from the bottom. We have cosine, sine plus sine over a cosine times a cosine over a cosine plus 1. We can do one set of and now I have to figure out what else could I simplify. If I look at the cosine times sine plus the sine, what are those? Take out a sine, very good. They have a GCF. They have a GCF.
Like I said, not even a
That which was just demonstrated.
You didn't write it though. Wait, I care about
Ma'am,
Easier way of.
there's an easier way?
Apparently. I don't know. I'm no math teacher, so I don't know what I'm doing.
Let's Google it. I'm checking the Google answers.
Yeah, did I do it right? Yeah! You go, Sarah! Hey, I got part of this.
Or you could do that all in one step.
I'm so glad. You go, Sarah. This is why I love you.
Wait.
Oh no. It doesn't work. You gotta say.
Oh, all right, it's 2 steps. I see what you did. Okay.
Okay, you're good. You're good.
Yeah, but not.
Just quick way as well.
It's like 2 people.
It's very similar to how I did it.
Wait, you have this number on there?
No, it's just at the answer key.
Oh, okay, I did.
Yes, I have the smart board.
This is a
Looked at it and then passed out the bathroom. Then walked to the nurse's office, passed out over there, and then he moved the chair to the nurse's office. Then
As well.
she has a brother in your group. It's like low iron. She's like great. She's like
This is so great. You guys are going to be rather upset with me. Hey, what do these 2 guys have in common?
Side.
I did that. Cool.
Damn.
I did that. Yeah.
What the heck?
Never even thought to occur to me to do that. Nicely done.
Never thought.
Nicely done.
I thought someone said we did like 8 or 9 steps.
There are. I didn't. You know what? Apparently there are shortcuts that you'll find. What's that? You're right. I might not have been.
I feel like I'd be a math teacher, but like no. Sorry. I wish you were my math teacher. Kick her out.
Wait, if I actually have, now hold on, are you making me have to write somebody up for the first time in like 3 years?
Don't let her get
You know what? They will freak out downstairs if they see paperwork coming from me. Wait, Murphy wrote somebody up is what they'll say. What did this poor sap do?
Number 5, that doesn't seem too easy.
What was the last time you had to write something? Did you just say that seems too easy?
5?
Oh, yeah, this one is really too easy because we did this problem before. We did one very similar to that. We had to do that with when we did the equations. If you just rewrite cosine or as 1 minus sine squared, you get 2 sine squared. So, yes, ladies and gentlemen, these are painful. These do take time to get through, okay? These that were thrown in here are kind of trickier of the styles. But if you, I gave you guys that other sheet yesterday, didn't I?
Yeah.
Okay. Yeah. What I'd like you guys to do work on this weekend then?
Is he sleeping?
No.
Yeah.
Catch up on the Z.
I'd like you to go through the 31 through 49 odds on here.
Are we ever gonna turn this packet in?
No.
Wait, okay, 30.
Okay, who did I get this from?
I think it was probably.
Try and go 39 through 49 on 31 through 49 odds on that one. I will have,
On the one you gave us yesterday?
yeah, I will have an answer key. It's on my yellow legal pad. I will have it on my desk Monday morning for you guys. I will probably write some of the answers on the windows Monday morning as well. You can stop by and see your answers, see how you did.
On those windows?
I can write them.
From the buses?
The resolution might not be as clean because I'm not very good at writing backwards.
Joy.
Well, Blonde, will you and Jory please go downstairs? I'll just get a twofer.
Wait, what is this?
Who's the third? So, also, a little quick something about next week's little test quiz thingamajiggy. What I've decided to do, how many of you guys are taking the AP Euro thing on Wednesday?
Thursday.
Thursday, okay, so just 3 or 4 of you guys? Okay. Oh, okay. What I'm looking at doing on Monday is the last little work through on some of these things. I will probably start a couple more equations that have some properties. When it gets to equations with properties, they're not going to be this god-awful, just so you know. So what I'm going to derive here, since we haven't had a test yet, I'm going to have 2 simplify, 2 verify, and 2 equations. One that is a general solution, and one that will be a within one revolution solution. Probably Wednesday or probably Thursday of next week. That'll get us then on Friday we can start doing sequences and series, which means we get to have a calculator again. Yeah.
If I write a really super elaborate pun on the back, will I get extra credit?
No.
Well, like, what if it's like a page long?
No.
You are?
If I do really bad in math.
No. So if you look at it like this, this is the last ditch of what generally works out to be the hard stuff in this class. Starting the last month, we take about a week, 6 days or so to get through sequences and series. It does not take long. And then we spend 2 weeks in probability and statistics land. It's a lot of fun. We will play cards, we will flip coins, we will gamble, we will do things like that. We will do stuff like that. And then I'm still buffering in a good 4-day solid review prior to the final as well. What sucks for you guys is that your final would be on that Monday. So good luck with that. Yeah, 2 simplify, 2 verify, 2 equations.
No way.
Yes.
Is that what you sub this for?
It'll be trig equations that you'll have to do some simplify. You don't have like a trig or anything in here. It's, you know how we did the ones last time where it was like a sine squared plus cosine, you had to rewrite the sine squared as cosine squared? It'll be like that, but I'm going to mix it in with the tangents and cotangents. Okay? Alrighty?